Hello, my topic was diagramming in requirements engineering. I was an employee at Shopify for a year and a half, and we did offline payments as a feature. So today I'm going to be talking about how we implemented this feature using system modeling and the approach that we used, and which sequence of diagrams worked best for us. This is a 5-page paper because we did 10-point font over here. It reduced it and it is short and sweet, and it has all the diagrams that we use. So first we're going to have an abstract and index terms. We have our introduction. We have our related work. We have our proposed method, the diagrams that we selected and everything. After that, we are going to have our experimental data, the overview, the approach that we took. I'm going to go into all of these diagrams. After the experimental data, we will be talking about the results. So the results is going to be what we found. We're going to use real numbers that we saw, as well as our conclusion, our acknowledgements, and then our references with a summary about me. So some inspiration that I took on top of the IEEE guidelines of 10-point font, and then 24-point font of this, and then 2 columns, and kind of how to do this. I also used 2 papers as a reference. So this paper is a discrete math paper that I am part of doing research for with my professor. And so I just kind of really liked the layout of this paper. So I used this as an inspiration. The librarian also showed me this paper that I also used as inspiration to write my paper and get some idea of how to write it and everything. I also used this as a reference in my own relevant paper, so it was relevant stuff. All right, so let's get into it. So at Shopify, Shopify is an e-commerce company. It's kind of like Amazon, but for small businesses. When you buy something, Shopify basically has card readers that you can purchase and put your card in, and you can make a payment. Usually this only works if you're online. So if the merchant is offline, like if you're in a remote place and there's no Wi-Fi, you are not able to make a payment with your credit card on the system. You have to use cash only. And so that's why we're talking about offline payments in the point of sale systems. And point of sale is basically anywhere where you can buy things. So the abstract is the integration of offline payment processing into mobile applications is a complex endeavor. So Shopify has a mobile app that you use for payment processing. So this study is basically going to talk about all the diagrams that we used when incorporating the offline payment capability. And this case study evaluates what would be the best sequence of system modeling diagrams for an e-commerce company like Shopify when implementing the offline payments feature. So we have our index terms and we have our introduction. So this paper is a case study, and we're going to find the best sequence of diagrams when implementing the offline payments functionality. We do have some related work. You can see that this challenge arises from malicious customers continually making false transactions without having necessary funds, which cannot be verified in offline setting. For example, if you are trying to purchase something, you can actually give a fake credit card, and the system will not know if you are actually buying something or if you put the fake credit card, because it's not online. It cannot verify if you gave a real credit card or not. So that's why we really need to hash out the front end and back end, as well as integrations to make sure everything is correct. We also work with Stripe API, which is an external API, so that also adds more variability and difficulty. So the proposed method that we have in this section is we're gonna select some diagrams. So we actually have 7 diagrams that we chose to use at Shopify. We had these use case, activity, sequence, state, component, deployment, and class diagrams. And as a team, we voted, 95% of the team voted for this order, which was use case first to get the use case, then the activity and components to get a high-level overview of how the app will work. followed by sequence and deployment diagrams to understand how the details will work of front end and back end transactions and all those. Then we went into state and class to get the more object oriented feel. And then what we did was we did our data collection, analysis, and validation. Now we're going to go to the actual experimental data, what we found. So I showed the proposed method. Now we're going to talk about the actual data. So by doing this, we saw that we actually drew each of these diagrams, and I'm just going to give an overview. So this is very simplified because these are not the real diagrams, but it's very similar, and I'm just putting the scope of the most important stuff that we focused on. So for the use case, you have a store associate. They can process offline sale, record payments, sync transactions, view sales history, and the admin can do these things. So that's just a basic use case of configuring and all of those. Next, we have the sequence diagram. This one shows how you can launch the app, process the offline sale, and how you can sync and make sure you process everything. And this was very helpful to connect the front end and back end and really hash out. Our team had to go back and forth multiple times to really get the diagram to be perfect because there were a lot of different variables, especially with our external API with Stripe. The state diagram was also something that took a long time. Everyone had to make sure we had the minimum number of states to make sure we did everything that we need. So the app is launched and you can go to offline state and how you sync and everything, which was a really difficult part. Component diagrams were also here. So we are connecting with Stripe Card Reader, and we do kind of talk about how we sync everything together. Then we have our deployment diagram, which really shows exactly how we're going to be deploying, as well as our class diagrams, which is, the object oriented. And the activity diagram was very useful for new employees, as well as the non-technical people, as well as normal developers on how the app will work. So you will attempt an online payment. If the system is online, you can go ahead and forward the transaction details to Stripe and have Stripe process the payment. If the system is not online, you will have the offline status, and then you'll have to save the details and try again later. And some feedback that we got was that it was very clear and easy to develop. So part of our results that we're going to talk about, we're done with the proposed case study that the experimental case study that we did. The results is that the time efficiency actually was 33% reduction in the time. Before it took we estimated it to take 6 months. But after this, it was 2 months of writing all these diagrams and then 2 months actually developing. So from 6 months, we went to 4 months, which was a 33 reduction using this formula. And so this was a metric that we used. And then we also reduced the error from critical errors to 35% and minor bugs to 45%. The developer comprehension also went up on a scale of 1 to 5. And we got some comparative analysis and we got some great feedback. Conclusion and future work that we see are that AI and machine learning can definitely hone in some more, as well as seeing which diagrams are most beneficial at each stage and why. I would like to give some acknowledgement to the librarian Alexander Rodriguez for showing me different articles that I can use for my paper, as well as Elizabeth Miller, who helped me shape this paper, and also Dr. Borazjani for letting us do this paper and learning so much about the different ways to write this paper. These are also the references that I have, and here is a summary about me. As you can see, I have an extensive background in e-commerce system, and I've developed multiple successful projects in the point of sale domain. Thank you so much for your time.